Greetings again everyone, welcome back to my channel. Here we're going to solve this equation where we have 4 to the power of x plus x is equal to 60 and we are given to find the value of x. Now you can pause this video and see if you can try this one by yourself. You may also check out my math playlist to see how to solve algebraic exponential equations like these ones. Now you may want to save this video for future reference, so you can smash that like button and subscribe to my channel. Now let us see if we can solve this equation. We have 4 to the power of x plus x is equal to 60. In this equation we're going to use a special type of function called the Lambert W function. And this is a very special kind of function where we use this to solve equation where the exponent is in the power and also in the base. Now how this function works is that if we have an expression such as a times e to the power of a, if we were to apply a w function, so we bracket this expression and apply a w function, the result is just a. So what this means, rewriting our equation in the form a times e to the power of a, when we apply our w function to that expression, our result is just the value of a. So we start to solve our equation by rewriting our equation in the form of a times e to the power of a, and we start to do this by subtracting x on both sides of this equation. Now we have 4 to the power of x is equal to 60 minus x, and then we divide both sides of this equation by 4 power x. So on the left we know that this is just one whole, and then on the right we just rewrite this, so we just have 1, and we're going to rewrite the 60 minus x in this way. So we're going to have 1 is equal to negative x, start with negative x, then we have plus 60, we have this over 4 to the power of x. Now 4 to the power of x, we can use this algebraic rule or this law of indices here, where if we have 4 to the power of x, we know that is essentially the same as saying 1 over a, and 1 over a can be rewritten as a to the power of negative 1. So what we're saying is that we can rewrite 4 to the power of x with the negative x plus 60 using this rule. So what am I saying here? I'm saying that I'm going to write my equation in this way. So I have 1 is equal to negative x plus 60, and this also will be in brackets, and I will times this by 4 to the power of negative x. So this is what I'm saying, just having everything in one straight line. Now as we continue to write our equation in the form a times e to the power of a, we see this negative x here, and we see it also in the power, but here we see plus 60. We need to have this plus 60 here as well. How can we get it there? Well, we have this law of indices rule here, where we have a to the power of m plus n. If we want to have the m plus n, we can do this. So we have a to the power of m times a, which is the same base, and we power that by n. So if we have the same base, a and a, we just have that with different powers. So what this means, if we multiply this by 4 to the power of 60, then this should give us our result. And we have to do this also on the left hand side because an equation needs to be balanced. So we have 4 to the power of 60 times 1 on the left, and therefore this is equal to negative x plus 60, and of course we continue to put that in brackets, and we have this times 4 to the power of, we still have a 4 to the power of negative x, and as the base are the same, the 4 and the 4, all that we do is just to add the powers according to our law of indices. Now as we are saying, we are trying to write our equation in the form a times e to the power of a. Now if we look here, we see negative x plus 60, and in the power we also see negative x plus 60, but we don't see the value of e. So we can write 4 in the form of e by writing 4 as e to the power of ln 4. As we know, ln means the log of base e, where essentially what's happening here is that e is cancelling on the base in the log. So technically the ln and the e will be cancelled out, and the result is just our 4 here. So what I'm saying is that we're going to substitute 4 with our expression here. Now if you like this video so far, please remember to smash that like button and subscribe to my channel, and stay tuned as we will be solving more math problems like these ones. So we have 4 to the power of 60, and this is equal to negative x plus 60, and we have this in brackets, and we times this by this expression that we said earlier. We're gonna change or write 4 in the form of this expression. So we have e to the power of ln 4, we put that in brackets as that is actually 4 in another form, in the form of e, and we power that by negative x plus 60. Now looking at what we have here, we see that ln 4 is being powered, and in brackets we have also another power. So a to the power of m in brackets powered by n is equal to a to the power of m times n. And so with this understanding, we rewrite this expression here, applying our law of indices rule here. So we start by saying 4 to the power of 60 is equal to negative x plus 60, and we have that in brackets. So we're going to times this by e to the power of, and we start by having our negative x, and then we say negative x plus 60 in brackets times ln 4. Now let us observe what we have right here. We have e, and in the power we have negative x plus 60 in brackets times ln 4. Also here we have negative x plus 60, but what we don't have is this ln 4 being multiplied this expression here. Now we have to maintain our expression in the form of a times e power a, so we can apply this w function on this expression. We quickly resolve this issue by multiplying both sides of this equation by ln 4. So what that means is that the negative x plus 60 in the base is just going to be multiplying ln 4. So we have to do this on both sides, so we also have to do it on the left hand side. So on the left hand side we have ln 4 times 4 power 60. So rewriting our equation, we have ln 4 times 4 power 60 is equal to, and we have negative x plus 60 in brackets, and of course like we said that we're going to have this multiplying ln 4. And then we have this times e to the power of negative x plus 60 times ln 4. Now let us see if we have it right this time. So in the base we have negative x plus 60 times ln 4, and in the power we also have negative x plus 60 times ln 4. So here we have our value of a, here we also have the same value, which is also a, and this time we have the value of e. So what we're essentially saying is that if we were to bracket this expression, so let's just rewrite this. So we have ln 4 times ln 60. We're going to put this in brackets, and we're going to apply this w function here on the left, because we also have to do whatever we're going to do on the right, we also have to do it on the left, vice versa, it's just the same. So negative x plus 60 times ln 4 times e to the power of negative x plus 60, which is this part now is the expression of a times e to the power of a. So this now, we bracket this is what we really want, and we apply this w function. So what we said before is that if we apply our w function on this expression, what happens is that the result of this expression here is going to be a. So let us see what's happening here. We have w of, in brackets, negative x plus 60 times ln 4, and in the power we have the same. So what happened here is that having this w function being operated on a times e to the power of a, the result is just a. So let us just rewrite that. So we have w of ln 4 times 4 to the power of 60. We have this in brackets still, and this is equal to, so the value of a, which is negative x plus 60 times ln 4. And now from here we continue to solve the value of x by dividing both sides of this equation by ln 4. So we do that here as well. So we have w of ln 4 times 4 to the power of 60 over ln 4. So on the right the ln 4s are cancelled out, so we rewrite this as w of ln 4 times 4 to the power of 60, that's in brackets, and this is going to be over ln 4. And we have this being equal to negative x plus 60. So we have negative x plus 60, and we solve x again by subtracting 60 on both sides of this equation. So from here we have negative x plus 60, and we are subtracting 60 here, so we have minus x plus 60 minus 60, and on the left we will also subtract this by 60. And we will also have to solve x by removing this negative sign, so we divide this by negative 1, and the result of what we have on the left, we also divide this by negative 1 as well. So let's just rewrite this and see what we actually have. So what we have is that we have 60 minus the value of w of ln 4 times 4 to the power of 60 over ln 4. and this all equals to the value of x. Now from here, to solve the value of x, we have to plug this into our calculator. So we go to Wolfram Alpha and we use our Lambert W Function calculator to find our value of this expression. So if we look here, we see that our decimal approximation is the value of 2.9175. So x is equal to 2.9175, and this is to 4 decimal places. Now we can verify our solution for x by plugging in this into our calculator. So we have 4 to the power of x. We say that x is 2.9175. So we have 4 to the power of 2.9175. And we add x. So we know that x again is 2.9175. So we add that to that. And we should get back 60. So let's see what we get here. And there we have it. The result is 60. So our answer for x is indeed true. X is indeed equal to 2.9175. Thank you for staying tuned with me to the end of this video. I hope that this was very informative. Please remember to hit that like button, share and subscribe to my channel to see my latest math videos on how to solve other algebraic exponential equations. And until then, I'll see you again soon. Thanks again and take care.